All right, so we are getting a little review of graphing systems of inequalities. So we started doing this last class. So this is the one we did last class. We did number 1. And what we did was we had to turn both inequalities into slope-intercept form. So that's that y equals mx plus b form. Because if they're in standard form, they're going to be pretty challenging to graph. So we want to change it into y equals mx plus b. So we changed that for each equation. And from there, we graphed the two lines. We shaded either above or below, depending on the inequality symbol, what it was saying. We had dashed lines because they were both greater than, less than, they weren't or equal to. And this overlapping shaded region, that's the area where all of our solutions are. So we tested some points. We said this point here at 2, 4 is not a solution. That's why I put an X. Also, this point here, at 2, -3. Even though it's on both of the lines, since the lines are dashed, it's not actually a solution. If they were solid lines, we said yes, they would be a solution. And finally, then we talked about, well, what is a point that is a solution? And this point right here was an example of a solution. Any points that are in this overlapping region, those are all solutions to the system of inequalities. These are all points that if we plugged them into each inequality, it would make the system true. It would make true statements. So let's get a little bit more practice. We're going to do one together, so everybody's going to do this one with me through the video, and then I will post additional videos. If you're still struggling, make sure to check out those videos, but if you feel ready to go, then you can just feel free to watch this video, and then you can do the rest without the videos. Okay, so we've got two inequalities, and I want my inequalities to be in y equals mx plus b form. Now, obviously, we're not going to have an equal sign because these are inequalities, but we certainly do need to change things around for the first one. So we have -x plus 3y is less than 21. And I need to have y equals mx plus b. So we're going to add x to both sides. And we're left with 3y is less than x plus 21. Almost done. We need to divide everything by 3, divide by 3, divide by 3. And we're left with y is less than 1/3 x plus 7. So this is the first line we're going to draw. Notice y is less than, that's the sign that we're using, so think about, should this be a solid or a dashed line? This should be a dashed line because it's not less than or equal to, it's just less than. So we've got a y-intercept at 7, so 1, 2, 3, 4, 5, 6, 7. And it has a slope of 1/3. So that means we're going to go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And to make our line, to really get a good idea of our line, let's go ahead and pick some more points to the left. So down 1, 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. So this is good. So we definitely have a good idea of what our line is going to look like. You can certainly use a ruler to line up and make this line if you want. I'm just going to kind of eyeball it here. It's going to be a dashed line. So make sure that it's very clear that it's dashed. And I put my little arrows on the end to indicate that it's a line. Okay, now the last thing, y is less than this. So less than means that it's going to be below the line. So that means if I'm at my line, I put my pencil on the line, I'm going to shade below that line. Okay? And you don't have to use two different colors, but I like to use two different color highlighters or pens or pencils so that I can really see which of the regions is overlapping. Okay? If you're having trouble doing figuring out whether it's below or above, use a test point. Pick the point 0, 0. Plug in 0 for x and 0 for y, so test it. Let's see. I'm starting with y is less than 1/3 x plus 7. If I test 0, 0, I plug in 0 for x, 0 for y. So let's see if this is true. 0 is less than 1/3 times 0 plus 7. Well, let's see if that's true. That's 0 is less than 1/3 times 0 is just 0 plus 7. 0 is less than 7. Is that a true statement? 0 is less than 7? Yes. So that means that 0, 0 is a solution, so we would shade over that area. If we found that 0, 0 wasn't a solution, then we would shade above where 0, 0 would not be found. Okay, so there's our first line. Let's look at our second one. Y is greater than or equal to negative x plus 4. Now this is nice. This is already in y equals mx plus b, so we can go ahead and graph it. So it has a y-intercept of 4 and a slope of negative 1. So y-intercept of 1, 2, 3, 4, and a slope of negative 1. That means we're going to go down 1, right 1, down 1, right 1. Continue that pattern. More dots you put, more points you put, the easier it's going to be to graph your line. But you don't have to put a dot on every single grid line. So should this be a solid or dashed line? Because it's greater than or equal to, it should be a solid line. So we're going to make a solid line, draw our arrows at the end. Now we got to figure out how we're going to shade. Y is greater than or equal to this. So that means it's above this. So we're going to shade everything above this. Again, I know it might be kind of hard to tell what's above this graph. So if you are having trouble just seeing, I just draw above it, use the test point, test 0, 0. 0 is not a solution, so it's not over where 0, 0 is found. So let's look at our overlapping region. So our overlapping region is this region right here. Okay, it's this triangle region. It's usually going to be a triangular type looking thing. All right, so let's talk about some solutions. What if I plotted a point here? Would that be a solution to our inequality? No, because it doesn't lie in the overlapping area. How about here? Does that lie in the overlapping shaded region? No, so that's not a solution. But if we put any points in here, 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 anything that's in that overlapping region, yes, those are all solutions. Okay, so you have some options. You can either try the rest of this activity on your own, or if you want some more support, I will post additional videos so that you can watch those videos and check out those examples. Good luck.